Hello everyone, today I want to explain about the thermochemistry. This is one of the part in the first law of thermodynamics. It is the study of heat change or enthalpy change in a chemical reaction. That is called thermochemistry. When a reaction is proceed, reactant to convert into product, that time energy may be absorbed or energy may be lost. So that we can determine by using the thermochemistry. Enthalpy of reaction is the one of the term involved in the thermochemistry, that is represented by delta RH or delta H or old term, new is delta RH. So what is the definition of enthalpy of reaction meaning? Change in enthalpy, or you can use the word enthalpy change, accompanied in a chemical reaction, or that may be process also. That is called enthalpy of reaction. In case you don't know the word accompanied mean, you can write change in enthalpy involved in a chemical reaction. That is called enthalpy of reaction. Then for example, A moles of A, B moles of B gives rise to C moles of C, D moles of D. This is a enthalpy of reaction may be plus mean endothermic minus mean exothermic x kilojoule mole inverse. Similarly, here one general example taken N2 plus 3H2 in gaseous state gives rise to 2NH3. Enthalpy of reaction is minus 92 kilojoule per mole. Similarly, any other reaction also you can write. For example, carbon, that is a graphite in solid state, and plus oxygen, that is a gas, gives rise carbon dioxide. Enthalpy of reaction is minus 393.5. This is a exothermic reaction. After this, we can measure the standard enthalpy of reaction. This is called enthalpy of reaction measured at standard condition. Otherwise, we can say this is the change in enthalpy accompanied in a chemical reaction when all participating substances are at the standard condition. So generally it is a representation delta RH, but the superscript is indicating here standard state. So here the definition once again I am representing here. The change in enthalpy involved in a chemical reaction or maybe that process when all the participating substances are in their standard state. Then you may know that what is the standard state. You may ask this type of question. Standard state meaning if concentration they may give, that time that concentration should be 1 m concentration and pressure should be 1 bar pressure. Temperature will be depends, it is not fixed. Therefore here as it is the previous equation I took here, but the standard enthalpy change of this reaction is 92 kilojoule per mole. Similarly graphite also I took graphite combustion, that will be gives a carbon dioxide. Its standard enthalpy change is minus 393.5 kilojoule per mole. So that is the standard condition I mentioned later. So same thing whatever I explained, that concentration should be 1 m concentration and pressure should be 1 bar pressure. Temperature should be, it is not mandatory to exactly define. Temperature will be different for the different substances. Therefore, generally it is a room temperature. Room temperature is the 25 degrees Celsius. Otherwise, in Kelvin, this is taken as a 298 Kelvin. So it is a different for different substances. Then one of the example taken as here iron. For iron, the standard temperature is 500 Kelvin. Next, enthalpy of phase transformation. First, we should know that what is the phase transformation. For example, solid convert into liquid, then that is called one of the phase transformation. Any one physical state convert into another physical state is called the phase transformation. So solid convert into liquid is called the fusion at this melting point. Liquid convert into solid, it is its reverse, that is called freezing. Liquid convert into gas, that is called vaporization at boiling point generally. And gas convert into liquid, that is called condensation. And next, gas convert into solid directly, then that is called solid convert into gas, that is called sublimation. Gas convert into solid also possible, that is called Hoare-Frost process. Generally this is not represented in any one of the book. I am giving this, you have to remember that generally gas convert into solid is called Hoare-Frost process. Then one of the first definition in this one is a standard or molar enthalpy of fusion. Fusion mean what is that? Solid convert into liquid. That is represented as delta FUS mean fusion and H standard state. So now onwards whatever we are discussing, that is one mole respect or standard condition respect. That's why all are the standard enthalpy changes only. The change in enthalpy of 1 mole of solid substance to convert into its liquid, that is called standard molar enthalpy of fusion, or simply it is called molar enthalpy of fusion. Now, condition H2O solid, that is called ice, convert into H2O liquid at the standard conditions. It is enthalpy of fusion 6 kilojoule per mole. Reverse reaction of this one is known as freezing. So when you reverse this one reaction, H2O liquid convert into H2O solid, that is called ice. That time its enthalpy is minus 6 kilojoule per mole. So when you reverse that, that enthalpy change will be remain same but sign will be changed. That is called Laplace-Lavoisier law. So you have to remember that when you reverse the equation, enthalpy will be remain same but sign will be changed. The next one is standard or molar enthalpy of vaporization. This is denoted with the delta vaporization VAP and H standard condition, that is a subscript. Now, here definition is same similar to the standard or molar enthalpy of fusion. The change in enthalpy or the amount of heat required to vaporize the 1 mole of liquid into its gaseous state or vapor states, that is called molar enthalpy of vaporization or standard enthalpy of vaporization at constant temperature and under 1 bar pressure. That is nothing but standard pressure only. So keep in mind these definitions are important for board level. Now H2O liquid converting into H2O gas, the enthalpy of vaporization, it is a positive value because we are heating, therefore positive endothermic 40.79 kilojoule per mole. When you reverse this equation, then H2O gas convert into H2O liquid, and this is known as enthalpy of what is that gas converted into liquid, that is condensation. And this value will be same but sign will be changed. So now see here, H2O gas converted into H2O liquid, the enthalpy of condensation at standard condition is minus 40.79 kilojoule per mole. Similarly, we can define one more phase transformation, that is the third one, that is called standard or molar enthalpy of what we can say sublimation. Because remaining all reverse reaction we are discussing, therefore now standard or molar enthalpy of sublimation, delta SU B means sublimation at the standard condition, that enthalpy change. So definition, every definition start with the same term, the change in enthalpy or enthalpy change. So the change in enthalpy of 1 mole of a solid substance convert directly into its vapor state or gaseous state without converting into liquid. Directly meaning what is that? Without converting into liquid, directly it convert into gas at constant temperature and pressure. That may be 1 bar pressure, standard pressure, under 1 bar pressure. That is called standard or molar enthalpy of sublimation. One of the example I am taking the solid CO2, that is called dry ice. So it is important for the board level or important for the compute level. Which of the following is the dry ice, like this compute level may ask, or board level what is the dry ice formula they may ask. So CO2 solid converted to CO2 gas, its sublimation enthalpy is a positive 25.2 kilojoule per mole at 195 Kelvin. Now the question they may ask, what is the dry ice? What is the dry ice? Solid CO2 or solid carbon dioxide is called dry ice. Now you should know that another example, that is naphthalene. Naphthalene is a two benzene ring fused, then its solid state. We know that that is used in the toilets or in the uh, clothes for keeping the insects to avoid. Therefore, naphthalene converted into solid to gas, that value is 73.0 kilojoule per mole. This enthalpy of sublimation is a combination of enthalpy of fusion plus enthalpy of vaporization. So keep in mind this enthalpy of sublimation depends on intermolecular forces. Higher the intermolecular forces, not only sublimation, any enthalpy of reaction, that is maybe phase transformation from solid to liquid, liquid to gas, anyone, that depend on intermolecular force. So one of the example here taken the enthalpy of sublimation, that is directly proportional to the intermolecular forces. Higher the intermolecular forces, higher the enthalpy change. Maybe one of the example I am taking here, that is called one of the question form only. Which of the following has a higher enthalpy change? Maybe sublimation, maybe vaporization, or anything. Higher enthalpy. Then example is here vaporization taken. Example which one? Water molecule. Second one acetone. Acetone molecular formula, what is that? CH3 C double bond O CH3. This is a acetone organic liquid, and C is a both A and B and equal. Both A and B has a equal enthalpy of vaporization. Now, how to decide? First we should know that which type of intermolecular force involved in these liquids. So we know that generally water molecule has a hydrogen bond due to electronegativity difference of the oxygen and hydrogen. So this is a hydrogen bond. And next, acetone, by using the dipole moment, it is one of the dipolar molecule. It has a dipole not equal to 0. It do not showing the hydrogen bond. That's why dipole force will be present. So positive, negative, some intermolecular force is present. That is called DD force or dipole force. Dipole dipole force is somewhat weaker than the hydrogen bonding force. Therefore, a strong intermolecular or strength of the intermolecular force, strength of the bond is hydrogen bond is greater than dipole dipole force. Therefore, which one has the highest enthalpy of vaporization? H2O or acetone? H2O has the higher enthalpy of vaporization. The next one is enthalpy of reaction does not depends on. It is one of the question. Options are just observe and answer it. Physical state of the reactant and products. Next, allotropic form of the element. Next, C. Initial and final state of the reaction. Then D. Intermediate steps involved in the reaction. Physical state is responsible because solid, liquid, anyone that responsible for the reaction. So intermediate steps are not because it depends on path because it is state function. So physical state allotropic forms and initial final state will be the responsible for the enthalpy, but intermediate steps are not responsible because enthalpy is the path function, not the state function, but not the path function. Therefore, enthalpy of reaction does not depends on the intermediate steps of the reaction.